All right, hello once again. This is Jeff Scott of Rankin Technical College. I'm at the school, so it's going to look a little different as far as the presentation goes, but I've been going through the PowerPoints for Tony Gaddis's Starting Out with Java Early Objects 5th edition. I'm up to chapter 7 of 16. This is a very important chapter, and it's on arrays and the array list class. So, we're going to be introduced to arrays, and I'll give you my own little introduction. Talk about how to process array contents, and one of the things that you'll learn right away is arrays and loops, especially arrays and for loops, work hand in hand. Passing arrays as arguments to methods, some useful array algorithms and operations, how to return an array from a method, arrays of strings, arrays of objects. We'll talk about a couple different searching and sorting algorithms, those being the sequential search and the selection, sort, and binary search. Two-dimensional arrays, which basically is like a spreadsheet. Arrays with 3 or more dimensions. And then we'll look at that mysterious string bracket args that we have in our main and see why that's in there. And finally, the chapter will end talking about the array list class. So, the problem that you have with primitive variables is, let's say let's suppose I was teaching a class at a university and I had 500 students. Well, with 500 students, the big problem would be that if I gave a test to each student, I could say student 1, student 2, student 3, and I'd have 500 different variables. Well, because if that's all I did was able to do would be to work with primitive variables. But with an array, basically it's one variable that has 500 components, okay? Arrays, as it says there, allow us to create a collection of like values that are indexed. An array can store any type of data, but only one type of data at a time. Now, some programming languages allow you to create an array. For instance, I could have created an array for a person where I had a combination of strings and booleans and integers and floats, etc., not Java. With Java, I need an array of strings or an array of ints or an array of floats, etc. All right, so an array becomes a list of data elements. And let's just take a little break here kind of for a second, and I'm going to minimize this and this. And I'm going to show this to you my way, whether this is good or not. This is the way I typically end up explaining arrays to people. All right, imagine, like I said, may not be the best of explanations, but it's the one I'm going to give right now. Imagine, and it's interesting because now I do, that I live in an apartment complex, all right? And you've got apartment 1, you've got apartment 2, apartment 3, and apartment 4. All right? And it's not my address, but let's suppose for a second that my address is actually 1234 Main Street, all right? Because it's an easy one for people to work with. So that's my address, 1234 Main Street, okay? And somebody sends me mail, but they don't have any idea they know my address, but they don't know the apartment number. Well, if I'm in apartment 1 and they send the mail to 123 Main Street and don't put any apartment on it, chances are pretty good that it'll still get to the right apartment. Not only that, as I'm finding out from previous tenants in the apartment, anyone who lived there in the past who is still getting mail at that address, I get their mail. So why am I telling you this? All right? The point is, the address of all these array elements is the same. All right? So the address is the beginning, so kind of like right here. That's 123 Main Street. What's different is the contents, apartment 1, apartment 2, apartment 3, those are the locations. And really, if we took those locations and we put them up here and said person in apartment 1, person in apartment 2, person in apartment 3, and the person in apartment 4. Then what we could put in here were the inhabitants at those addresses. So Scott was in apartment 1, maybe Jones was in apartment 2, maybe Green was in apartment 3, and maybe Black was in apartment 4, as an example. And again, they're kind of convoluted examples, but hopefully at least you see what's going on here. And there's a reason, as always, there's a meaning to my methodology here, even if right now it doesn't seem like there would be. All right? Arrays kind of work like this, but instead of this being location 1, 2, 3, and 4, the way that it works is with an array, it's locations 0, 1, 2, and 3. All right. Much of what's done in information technology is predicated on starting things with 0. All right. So again, take it one step further. I mentioned to you before, if I had 500 students and I wanted to create, they each took a test, and I wanted to put the grades, I could have test 1 equals 88. It would probably be an integer. Int test 2 equals 93, and I could do that 500 times until I had int test 500 equals 71. So I could do that, but I'd have 500 variables. And it's not that that's necessarily wrong or bad. It's just very long and very laborious to do that. All right, so instead I could do this. Int bracket bracket tests equals new int 500. Now I get myself an array that's got 500 elements in it. So tests 0 equals 88, tests 1 equals 91, 7, whatever, all the way up to tests 500 equal whatever we said it was, 91. And again, you might look at that and say, okay, I understand, but I'm not seeing where this is buying me anything. Well, I don't want to manually enter these tests. So probably I'll have those tests, all 500 of them, in a file. And I'll go through a for loop and I'll enter them by having it read through the file. And you can say, well, couldn't you have done that with just 500 variables? Yes, but it would have been more work, because here I've got one variable with 500 components. It's like I had one humongous apartment complex with 500 mailboxes in it, as opposed to having 500 different mailboxes, one for each person. That's what you get through the use of arrays. Now, I don't know how well that was articulated, but hopefully it made some sense to you. All right? So, as mentioned, an array is an object, so it needs an object reference. So notice, int bracket bracket numbers. And then here they say numbers equal new int 6. Now, normally you're not going to do this in 2 steps, but you can. I think the author is showing it in 2 steps like this to show you what's happening in each step. It's just like a variable. But here, instead of declaring a variable, you're declaring a reference to an array. And here, you're creating a new array. So again, that could have been in one line, int bracket bracket numbers equal new int 6. And this now becomes numbers 0, numbers 1, numbers 2, numbers 3, numbers 4, and numbers 5. They mention index in there. Quite often that's the name that's used, but the other name that's used a lot is subscript. In fact, the way this is normally read is numbers sub 0, numbers sub 1, numbers sub 2, numbers sub 3, numbers sub 4, and numbers sub 5. That's usually the way that it's read. So again, normally you do this in one step. You can have arrays of any type. The size of the array must be a non-negative number. I don't know why you would ever create an array of size 0. I don't know if it would take that because you couldn't put anything in it. All right. The size, when you figure it out, can be a literal value, it can be a constant, it can be a variable. So if I'm teaching a bunch of different classes and I have a different number of students in each class, I might ask how many students are in this class. And that variable, students, would become the length of the array. Now remember, since arrays start with 0, if I've got a 10-element array, it goes from element 0 through element 9. Once you create an array, it's fixed in size and it cannot be changed. One of the things I talked about in an earlier lecture was early binding and late binding. And I mentioned if something is early binded, what that means is at compile time, the system needs to know how much space in memory to put aside. An array is an example of something that's early binded. The compiler must know when the program is compiled how much space to put aside for the array and the kind of elements it's going to hold. That's why, as it says in that bottom bullet, once you create an array, the size is fixed and it cannot be changed. So again, how do you access these elements? Here is one way. Again, we say numbers sub 0 for subscript 0 equals 20. Array elements can be treated like any other type of variable. So an individual array element is virtually no different than a variable of that type. So if I've got an integer array then that's called numbers, number 0 would be almost as though I said student 0, same kind of an idea. Again, typically you use for loops with arrays. You don't have to do it that way. Normally it's done that way. Since array indexes start at 0, again, as they show in the example there, that array would go from index 0 through index 9 or sub 0 through sub 9. If I try to access something that's less than 0 or that's greater than 9, I get what's called an array index out of bounds exception. Remember, we talked a little bit about exceptions in a previous chapter, and we said by and large exceptions are not good things. In for loops, typically when you're looping through, you use I, J, and K. I do that. Sometimes I use LCV for loop control variable. You know, it's whatever's the easiest for you. Again, it's easy to get off by 1 errors. When you're creating an array, you don't go from 1 to 100 if it's an 100-element array. Instead, you go from 0 to less than 100. That's an off by 1 error. And you get the infamous array index out of bounds exception when you do that. It is possible for you to initialize an array when you create it. If you notice in the example that's shown right here, days, it's got how many days there are in each month. Two things about this. First thing, it bugs the heck out of some people that now January is month 0, February is month 1, etc. If that bugs you, then what you do is, instead of starting with 0, 31, etc., you put a 0th element in there and you put the number 0, comma, 31, comma, and you never use days sub 0. All right, I don't know if I can. Nope, I didn't want to do that. Darn it. Always restarts the time then. Yeah. But it is possible for you to do that. That's the first thing. Second thing is, please realize those are curly braces in there. If you use something other than curly braces, it won't work. Now, you don't have to initialize the array when you set it up. You've already seen that. You can set it up like this. You can do it this way, or you can do it this way. All right? Java programmers virtually always do it this way right here. The reason that this syntax is allowed is that's the syntax that's used in a language like C. And that's why it's allowed to be used in Java also. But virtually always you see at the top weight, and it's typically pronounced int bracket bracket numbers right there. So that first one that's shown is typical. You can declare multiple arrays on the same line, but I don't see the reason for doing that. I don't exactly see what that buys you. So again, in my classes, I ask that people put each declaration on a separate line. I think that just makes more sense. If you use that declaration, as they mention there, then you have to have the brackets after each variable that's going to be an array. So numbers would be an array, codes would be an array, scores would just simply be an integer variable. Processing the data in the array, so the individual elements, they're just literally treated as though they are individual variables. So anything you do with a regular variable, you can do with a single array element. You can use them in relational operations, you can use them in loop conditions. Arrays have a thing that's built in called length. Notice it's temperatures dot length right here, no parens. All right. This is a constant. This is not the same way that we used the length function for a string, because this is for an array. With a string, I believe we had parens afterwards because it was a method. Here it's considered a constant because you can't change its value. If I set up an array like this, this says the array is named temperatures. It's going to hold doubles, and there will be 25 of them. And they will be temperatures sub 0 through temperatures sub 24. But the length is 25, whether I count from 0 to 24 or whether I count from 1 to 25. The length is still 25. There is an enhanced for loop that you can use when you work with arrays. And you see it right here. The name of the array is numbers. Val is literally a variable that we're making up on the fly. So what this is saying is if I want to iterate my way or work my way through the array, not change it, but just print out its value, this is a little faster way than using a regular for loop. If that confuses you, you don't have to do it that way. It's just that's another way that you can do it. This is the way you see a lot. Again, starting with 0, ending with the name of the array dot length. All right? Now, I do want to mention something in here. Let me try to, because the author comes in here and says this. The author comes in and says, for I equals 0, I less than temperatures dot length, I plus plus. And then you've got your curly braces, got in here, do some stuff, whatever it is, and you end. That is totally legit to do that. I'm going to recommend you don't do it like that. I'm going to recommend instead you say something like this. Int len equals temperatures dot length and then put here len. So why would you do that? Well, here, one time, I am figuring out the length of the array, and then I'm checking it. If I do it the other way that I showed you previously, if we do this, it's not that it's wrong, but you're making the compiler check the length every time and do a calculation when there's no reason to do that. What if the array had 1,000,000 elements in it? Even though computers can do calculations unbelievably fast, you're still wasting processor time by having the computer figure out every time, all right, just exactly what the length is. So you're better off saying I less than len. You can let the user specify the size of the array. I already mentioned that to you. And that example they show there is virtually identical to the one that I mentioned to you, where you ask, how many students do you have in the class? Or maybe I have 100 students, but how many students actually came on the day of the test and took the test? You can assign the value of an individual array element to a regular variable. It's totally legit to do that. It says if the first array right here doesn't have a reference to it, it'll be garbage collected. So an array is treated like any other variable. All right. Reassigning array references says the numbers variable holds the address of an integer array. All right. So here you're having it point to a new array. So originally it pointed to this array with 10 elements. Now it points to this array with 5 elements. So this old array gets marked for garbage collection and eventually removed. All right? When you want to copy array elements, it is not, repeat this, it is not legal for you to just say one array equals another array. You can't do that. What it does instead is it makes both array 1 and array 2 now hold the same address, so they point to the beginning of the same array. If you want to copy arrays, you have to copy the elements one element at a time. So typically you do that inside of a loop, as shown in the example here. And you have to copy them one element at a time. If you pass a single element of an array to a method, then it's just another variable. Now, quite often when you do that, so if it's just a single element, it's passed in by value. If you pass an entire array in, not just an element, but an array, since it's an array as an object, you end up passing in the address. So any changes that you make, so we've got a method here called show array. If we change the value of any of these, if we were to change the value, it would be a permanent change. Again, comparing arrays, as we mentioned, if you use the equal, it only determines whether or not they point to the same address. If you want to compare the contents, you've got to write a loop and compare them element by element. Some useful array operations, and you'll have to read your book on this, and hopefully you've been reading the book throughout the entire course. There's a way of finding the highest value in an array. I'm going to assume that the first element is the biggest, and then I'm going to search from the element 1, which is the second element, to the size of the array minus 1. And if I find something that's bigger than my current highest, it becomes the highest. Highest and lowest are exactly identical except for two things. Rather than the word highest, you use the word lowest. Rather than a greater than sign, you use a less than sign. All right? If you want to add array elements, here's a way that you can do it. Now, if you've watched any of my C# videos, you'll notice that I created a program that had an array in it, and it was a GUI program where we would get the largest element, the smallest element, the sum, etc. I will replicate or do the same program in Java in a later lecture. Averaging the array elements, well, first we have to add them, then we have to divide by the array's length. Now this statement right here that says average equal, that's not part of the loop. This is only done once. It would make no sense to put it in the loop because then you're figuring out the average each time you're going through, adding a new number. Doesn't make sense. Java allows you to create what are called partially filled arrays. As mentioned, they're typically, if the amount of data that the array must hold is unknown, you've got, you could make it big enough for the expected largest thing that you put in here. So say this was students, and I knew I would never have more than 100 students. I could do this, and it would be fine. But what if I've got a small class that's only got 10 students in it? So my largest class has got 100, and my smallest has got 10. Well, then I'm really wasting 90 elements for that class that has 10. That's what they're saying here. Arrays work with files. In other words, you can read the elements of a file into an array. You can write array elements to a file, so it works both ways. So you can save the contents to a file, you can read the contents from a file into an array. And they show you some examples here. Again, those won't make sense until you take the time to literally go over what's going on here. It's totally legit for you to return a reference to an array from a method. So notice public static double bracket bracket, which means I'm going to return an array of doubles, or the address of an array of doubles. So I have to make sure whatever I return is a double array. Okay? You can have arrays of anything. You can even have an array of strings. So here's a bunch of names: Bill, Susan, Stephen, and Jean. So name sub 0 would point to Bill. Name sub 1 would point to Susan. Name sub 2 would point to Stephen. Name sub 3 would point to Jean. All right, we could do it with months. We could put anything we wanted to put in there. If an initialization list for an array is not provided, you must use the word new. So you notice in the previous example, the word new is not there because we are initializing the array when we create it. Also notice that when you initialize the array by using the curly braces, do not, repeat, do not put a number in there. Do not put a number in there. You let the compiler figure that out. All right? But here, when we use the word new, on the right-hand side, we have to let the system know how much space to put aside. When you create an array like this, then you must individually initialize each element. So that'd be another way that you could do it. Come in here and you'd say string bracket bracket names equal new string sub 4, which means they would all hold null. And then you'd come through there and say name sub 0 equal Bill, name sub 1 equals Susan, name sub 2 equals Stephen, name sub 3 equals Jean. Totally legit to do that. You see it done both ways. All right? String objects have several methods. We talked a little bit about some of these. Not only is there a 2 uppercase, but there's a 2 lowercase. So if we ran, notice we've got Bill, Susan, Stephen, and Jean here. If we ran the 2 uppercase on every element that was in that array, now we'd have Bill in capital letters, Susan in capital letters, Stephen in capital letters, and Jean in capital letters. Not only is there a 2 uppercase, again, there's a 2 lowercase. All right? The compare to will compare things one at a time. If it's comparing A with B, if A is greater than B, it'll return a positive number, usually the number 1. If A is equal to B, it'll return 0. And if A is less than B, it'll return a negative number, usually negative 1. You can get some ugly looking things in here, like they show the charat. All right, so this is the 3rd array element, really element 4, because it's 0, 1, 2, 3. So it's the 4th array element, and it's the first character of that element. All right, so name sub 3, here, 0, 1, 2, 3, that value would be the J in Jean. We already mentioned the length method. Notice it's final, which means that the array length is a constant. You cannot change the size of an array once you've declared it. So it is not possible for you to put the name of the array dot length on the left-hand side of an equal sign. You'll get an error if you try to do it. All right, so notice an array length is a field, so you just use length with nothing after it. The string length is a method, so you need the parens after it. So this says go through the entire array, and for each element of the string array, tell us how long it is. So for instance, in here, 4, 5, 6, 4, for example. Again, you can create an array of objects. So if I create my own class that's called inventory items, I can make an array of 5 of those inventory items. By default, if I create them this way, they're going to each hold null. There's nothing in them. So I have to fill them up individually. Now this description in units, I believe that was in the last chapter that this was shown. All right, so let's talk about some searching and sorting. The sequential search algorithm is what's known as a brute force algorithm, so it's probably about the worst way of doing things. All right, and Imagine if you had, I live in Lake St. Louis, and imagine that you had a phone book for Lake St. Louis, and you wanted to know my phone number. Okay? Well, in the best case scenario, all right, in the best case, what I would do is I would turn right to the S's in the phone book, and I'd find the SCs, the SCOs, and then look for Scott. If I found a bunch of people named Scott, I'd look for one named Jeffrey. Okay? That's the best case. But now imagine that the names in the phone book are not in alphabetic order. They're just thrown in there. All right? In the best case, Scott is the first one that's listed, and it's me. In the worst case, I'm not in the phone book because I've got an unlisted number. So the problem you get with a sequential search algorithm, it does use a loop, which can make it quick to go through an array. But the problem with that is, since it's not in any kind of order, you might go through the entire array to find out something's not there. So if I've got an array with 1 billion elements in it, and I'm searching for one thing, it's going to take maybe not a lot of time for the computer, but a little bit of time. All right? So the sequential search algorithm is fairly easy to write, all right, but it can be fairly laborious because on average you go through half of the array size looking for what it is you're looking for. So it makes sense, if you're going to do that, to sort an array, and one way you can sort an array is by using the selection sort. With a selection sort, you go through the entire array. So if it's got 10 elements in it, you go through all 10, you find the smallest element and put it in element 0. Then you go through it again, but you don't have to check out the 0th element because you know that's already the smallest. So you go through elements 1 through 9, and the smallest one in there becomes element 1. Then you go in 2 through 9, and you keep continuing this process until the array is in sorted order. Why would you want an array in sorted order? Well, having an array in sorted order can really help when you're searching the array for something. So what we talked about before with that sequential search was a brute force that'll work whether the array is sorted or not. If the array is sorted, you can use what's called a binary search. A binary search is also known as a halving search, Halving. So imagine for a second that I've got an array, and that array has got 10 numbers in it. And again, I'm going to put this in here, and I'm making these numbers up, so they don't mean anything. Two, 3, 4, 5, 6, 7, 8, 9, 10. All right, is that 10 numbers? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If I want to know whether or not the number 73 is in there, I'd have to look, in the worst case, through all 10 elements to find out it's not there. Not that that's a terrible thing, but imagine instead I put here 8, then 9. So I'm putting this in sorted order. 8, 9, 33, hopefully I'm not going to screw this up, 56, 78, 98, 111, 123, 234, and 567. Now they're in order. Okay? So what happens when I use a binary search is I go down to go halfway into the list, so about here. And I say, okay, the number I'm looking for is 73. Okay? Is that the number? No. Okay? Is it greater or less than that number? It's less. So in one swoop, I have now removed 1, 2, 3, 4, 5, 6 elements. So it either has to be one of these 4 elements or it's not in there. All right, so I cut the array of the 4 that's left in half again. And I say, okay, here. Is that the number? No. All right. Is the number greater or less than that? It's greater than that. So it either is that number, either that's the number, or the number does not exist in that list. Now, when I was younger, when my kids were younger, we used to play a guessing game. You know, guess the number, try to make time on a long car ride go away. So, you know, I'd say guess a number between 1 and 10, etc. And of course, you'd guess it. It wouldn't be that hard, even 1 and 100. But I'd say to my daughter, okay, give me a number between 1 and 1,000,000, and I'll figure out what it is. So she, you know, when she got older, she thought, well, I'm going to, you know, he'll never get this. I'll put 3, 4, 1, 5, 6, 7 as an example. Okay? So she'd say, okay, Dad, I'm ready. Guess. And I'd say 500,000. All right? And she'd say, nope, it's less than that. So I already know that I've removed half of the numbers that are in the list. All right? So with that one guess, I have now eliminated numbers 1 through 500,000. I'm sorry. Since I said it's less than that, I've now in one guess, I've eliminated numbers 500,000 through 1,000,000. So she says, guess again. So I cut the list in half again, and I say 250,000. And she said, nope, it's higher than that. So now I know that these numbers have already been eliminated, and now so have these numbers. So in 2 guesses, I've eliminated 750,000 plus of the possibilities. So I cut it in half again. And I say, okay, 375,000. She said, nope, it's less than that. So I know now the number must be between 250,000 and 1 and 374,999. So again, I keep eliminating them. So I don't know what half of that would be, but let's just assume I say 300,000. In fact, let's say I say 325,000. All right? She says, nope, it's bigger than that. So now I've made 4 guesses, and I've eliminated all the numbers. I've eliminated all the numbers between 1 and 325,000. So that's 325,000 right there. And I've eliminated all the numbers between 500,000 and 1,000,000. Now, I don't know exactly how many that's going to be. That's 325,000 and 500,000 approximately. So that's 825,000, or 82.5% of the numbers have been eliminated with just 5 guesses. All right? So I know now that the value must be between 250,000, between 325,000 and 1. So what's left, and I'll remove this in a second, it must be between 325,000 and 1 and 374,999. So notice the range now is less than 100,000. In fact, it's really less than 50,000. So I again cut it in half, and I say 350,000. All right, so I come in here and guess again, and I guess 350,000. And she said, nope, smaller. So now I know that the value must be between 325,000 and 1 and 350,000. So in other words, I've cut it down in 1, 2, 3, 4, 5, 6 guesses. I've cut it down to a range of 25,000. All right, I again keep doing this, and I guess half of that again, so I say 337,500. She said, nope, it's larger. So now in 7 guesses, it's got to be between 337,501 and 350,000. So now, as you notice, it's down to like 13,000. So I check again. And I say 343,000. She says, wow, you're really getting close, but it's less. So now I know it's got to be between 337,501 and 342,999. So notice in 1, 2, 3, 4, 5, 6, 7, 8 guesses, I know that I'm within 6,000 of the number. So I guess again. All right, and it's, well, I said 343,000. It was 341. All right, so it's less here. So now I know it's got to be between, all right, it's got to be between what? 337, yeah, it's got to be between these two. I guess that's right. All right. So I guess again, and it's got to be between these two. So I say 340,000. She said, Dad, it's higher than that. But now what's left? Well, I know what's been eliminated are the numbers 1 through 340,000. Those are all gone. Can't be one of those numbers. And I also know it can't be a number that's greater than 343,000. So 343,000 through 1 million. Those are gone. So I know now with 1, 2, 3, 4, 5, 6, 7, 8, 9 guesses, in 9 guesses, I know now that the number must be between 340,001 and 342,999, something like that. So notice now in like 9 guesses, I've eliminated virtually about 99% of the numbers. That is a binary search. Now, to put it in perspective, one other way, what I've seen people do in the past, and don't ask me why they do this, I don't know, but I've told this story before, that I remember years ago, back when Bob Barker was the host of The Price is Right, and watching an episode during the summer. And they brought a gentleman up on stage, and they had a refrigerator. And he basically had to guess the price of the refrigerator, and he had a minute. And he said, $700. And they said, higher. And he said, 701. And they said, higher. He said, 702. And I kept thinking, you're not going to win. You say $700, and they go higher. You say $1,000, and they say lower. Now in 2 guesses, you know it's got to be in between there. You say $825, and they say higher. All right, you say $900, and they say lower. Now with 3 or 4 guesses, you know it's between $825 and $900. $850, higher. $875, higher. So now it's between $875 and $900. You keep cutting it in half every time. That's a binary search. All right. A 2-dimensional array is basically like a spreadsheet. But if you're working with an Excel spreadsheet, the columns are A, B, C, D, and the rows are 1, 2, 3. If you're working with a 2-dimensional array, it's always rows first, then columns. So you do it in a row column order. So this would be row 0, column 0, row 0, column 1, row 0, column 2, row 0, column 3. Row 1, column 0, row 1, column 1, row 1, column 2, row 1, column 3, etc. When you declare it, you need 2 sets of brackets, one for the rows, one for the columns. Those 2 sets indicate that it's a 2-dimensional array. And you can always tell how many elements there are by multiplying the one index by the other. So this will have 12 elements. And you see them there. Again, when you process the data in a 2-dimensional array, each element has 2 subscripts, one for the row and one for the column. All right, so it looks a little ugly, but it actually makes perfect sense when you think about it. So notice score sub 2. So that says row 2, row 0, row 1, row 0, row 1, row 2, and that says column 1, column 0, column 1. So that's why the 95 is in that column. You can work with a 2-dimensional array, but when you work with a 2-dimensional array, let's put it this way. For every dimension that you have in an array, you'll have another for loop. Now, if you remember earlier, I showed you an example of nested loops like this, but they weren't done with an array. I showed you an example of a clock. All right? So you'll go row 0, column 0, row 1, column 1, row 0, column 2, row 0, column 3, row 1, column 0, row 1, column 2, or row 1, column 1, row 1, column 2, row 1, column 3, etc. And you can put values in, you can get values out by using loops within arrays. And it doesn't matter how many dimensions they have. You can use arrays of, you can have an array of whatever dimensions you need it to have. Now when you do this, you should enclose each of these in its own set. Okay, so that would be row 0, that would be row 1, that would be row 2. Row 0, column 0, row 0, column 1, row 0, column 2. Row 1, column 0, row 1, column 1, row 1, column 2. Row 2, column 0, row 2, column 1, row 2, column 2. All right, so as it says there, that would declare an array with 3 rows and 3 columns. Okay, there's how you'd initialize it, and there would be the results. Two-dimensional arrays, as it says, technically it's an array of one-dimensional arrays. The length field gives the number of rows. Each row has a length constant that tells you how many columns there are in that row. But since you can have partially filled arrays, each row can have a different number of columns. So you can do something like this. Sometimes this is known as a jagged edge array because they're not all the same. Here's how you would sum the elements of a two-dimensional array. Very similar to what we saw before, but again, we've got a loop within a loop. And there's an example of it. You can pass an array of any dimension, so a one-dimensional, two-dimensional, or other array, to a method. But the method must accept it as a parameter. So notice here we're saying when you accept it, you have to put bracket in the actual method is what they're saying. I already mentioned ragged arrays to you. When the rows of a two-dimensional array have different lengths, the array is known as a ragged array. You can create a ragged array by creating a two-dimensional array and not specifying the number of columns. All right? It's used, it has its purposes. You can have arrays of as many dimensions as you want, but since no one that I know of can think in dimensions outside of 2, and it's even that's hard, of 3 I should say, and even 3 dimension is hard enough, you typically will not see arrays that you can't visualize, so that are more than 3 dimensions. All right, the chapter is just about over here, so we're going to talk a little bit about command line arguments. You know what this is. You know that main is a public method, which means it can be called from outside of the class. We know that it's static, so there's only one of these. So no matter how many objects we create of it, there's only one main. We know main doesn't return anything, but main can have things passed in. Everything that gets passed in is part of an argument array. Now you know what that means. That's called args. So if I wanted to, I could run a program, all right, that was called command line, and I could say, how does this work? And what the system would do, I could put all that in there when I run the program. There are actually 4 different strings that I'm passing in there: how, does, this, and work. So each one of those would be args 0. This is wrong. That should be args 1, args 2, and args 3. It's not required that the name of main's parameters be args, but by convention, everybody does it. One neat thing about Java is it allows you to have a special type of parameter that's called var arg, and I believe it's called like a variadic or something like that, which means if you put in here int ... numbers, I can pass in an array of any size, and it will add up all the elements. So I can use one routine. As long as I'm passing in an array, it can be an array of any size. That's kind of neat. And there aren't a lot of languages that I know of, at least, that allow you to do that. All right. We mentioned before that when you work with an array, the good thing about an array is it allows you to have one variable that holds a lot of different elements. That's the good news. The bad news about using an array is once you create the size, you can't change it. But unlike an array whose size cannot be changed, you can have an array list. The array list, as mentioned in these two sub-bullets, automatically expands when a new item is added and automatically shrinks when items are removed. So it can grow and shrink as the program is running. So rather than it being early binded, like we mentioned before with an array lists are late binded, so they're done at runtime. If you want to use an array list, you have to import java.util.ArrayList. And the syntax looks a little funky. You say array and then an angle bracket string to tell the type, then the name of the, you say array list, then the type in angle brackets, the name of the array list equals new array list, and you've got that in there again, and then you put parentheses in there. And you put the parentheses in there because it is legitimate for you to put a number in there that say how many elements are in there. So this would say this is an array list that holds strings. There's a lot of different built-in array list methods. Add would add methods to an array. Size would tell you how many elements are currently in the array. Get, as an example, allows you to access a certain array element. You can use that enhanced for loop to iterate your way through an array. When we say iterate, we're meaning, work your way through the array. The array list class's toString method returns a string representing all array elements, so that's kind of neat. The remove method removes a designated element. So if we said remove 1, since remember, the first element is element 0, that would actually remove the second element. There is an add, there is a get and a set. There's all sorts of things that you can use with this. An array list has a capacity, but when the capacity is exceeded, so if I say I want to create a new array list, this says it has 100 elements in it. When I get to element 101, typically what happens is the size of the array doubles. So now it can hold 200 elements. You can store any type of object in an array list, which makes it unbelievably powerful. And they give you a programmatic example here of working with an array list. Now these are pretty complex topics. This is a pretty complex topic going through this stuff. All right? I would strongly recommend that if you want to learn more, and you've seen this from me before, just about finished with a lecture here, that you go out to java.sun.com and you find the Java APIs. Just grab the current one, and in here it's nice because we're right near the top, find array list. So there is array list. Then you can start to work your way down here and you can find all the different methods and all the different ways that this can be used. This is what I always do when I think to myself, Java must have a way to do this. I start looking through the API for something of a similar name, then I look through it to see in the API what methods are available to me. All right? So that pretty much concludes this lecture of Chapter 7. When I come back, which will be in my home tonight, I'm going to go into Chapter 8, which is text processing and wrapper classes. And then after that, I'm going to go through Chapter 9, which is on inheritance. All right? So I'll be back with those fairly shortly.